Several techniques will come into the question. Okay, multiple molecule when comes, we use a simple GCM, not simple GCMS. We go for the like different kind like very high resolution spectrometry. In a US, in a Florida State University, you can get it. You can send a sample, you get done it. It's one of the beautiful technique. It will give you complete molecular level analysis. You can get it any kind of molecule. You can directly inject a crude oil. You can say, for example, any kind of metal, it's a general. If you want to analyze it, I'll go one by one, how element can be analyzed. If you want this part, like hydrogen part, we are having the equipment CHNSO. Energy is absorbed by that particular atom, then that technique we call it as a absorption spectrum. Crude oil.
And then it converts into aerosol to the ground state atomic form. And it's the ground state atomic form that exhibits the atomic absorption phenomenon. So it goes through. So your sample, that heat basically breaks up your sample and it converts your sample into a gaseous form. And everything exists as in the ground state form. And then the lamp, why you're using a specific lamp? Because that lamp has the sufficient or the right amount of energy that will cause the adsorption process. So only that particular, once your sample have that particular element, the lamp will only have the right wavelength that will cause that adsorption process. Understand?
My point was not that.
No, your question I can solve.
I target my main point is
I can elaborate.
You mentioned two elements which can be used to create a flame. Why is those compounds? I mean, you say in order to have a flame, the flame will be of certain two compounds you mentioned.
Air acetylene.
Yes, acetylene.
So there's one flame, and then you have air acetylene, nitrous oxide. There are two different types of flame with two different temperature profile, and they're used specifically to overcome different types of interferences. So that's a whole different topic.
Yeah.
As you get deeper. That's
My question is why to use those compounds? You can have a flame by burning anything.
No, the flame temperature is different. If you use like acetylene and or nitrous oxide, one will give 2800 degrees Celsius and other will go to 3200 degrees Celsius, little bit high temperature.
So in a periodic table, that flame is the temperature.
Yes, in a periodic table, if you go to equipment itself will tell you which flame you have to use it for particular elements. If you go to software will tell you if it's an iron, whether I can use acetylene or I can use nitrous oxide. Equipment itself says you set acetylene or you set a nitrous oxide, based on you can select it. Okay. But this is an AAS case. But in ICP, there's a different process. Yeah, we are not injecting sample directly. It's the spraying. Sample is sprayed into the yes. It's in the sprayed. Okay. We will show you it in an instrument if you come. We can show you. Okay. So yeah.
No, I'm thinking the way we are using this element, for example, vanadium and the nickel in upstream exploration to trace back the condition or the environmental condition of source rocks where the oil comes from. So what are the concentration inside of downstream refinery, something like that? What are the level concentration of vanadium or what are those elements in the heat?
You mean to say the crude oil?
Yes, I mean the minimum concentration required.
No, it's a different. In many cases, it's a 0.01, less than 0.01%. See, when you take a crude oil, it comes. Sometimes it reaches up to 1000 ppm. In a crude oil, as such you take, total element composition will be, total is metal composition, I mean to say, it's around 1000 ppm. But when we purified it, if you go to a specific sample like a diesel, or it may be some other element sample, everywhere some specification are fixed. According to Indian government, we are going with a 0.01%, less than this. It's an acceptable limit for India. If you go to other, as like a sulfur also, come to the India, we have a 10 ppm limitation. total concentration of sulfur will be less than 10 ppm. 10 or less than 10 ppm, it's an allowed specification. Initially it was a 50 ppm, but in the US it was a 10 ppm initially also. So I mean to say, it's a country-wise it will be varying. Country-wise, the concentration varies. Okay, but you check it with your country specification. But what I meant to try to say is, in this one, like if you're asking me a vanadium or maybe like other nickel, we are getting like a 2 ppm, 3 ppm, 5 ppm like that in our samples. Okay, sometimes 0. 0 is not actually 0, it's a less than 1 ppm. Okay, in that case we write it as a less than 1 ppm. It will be there. We are unable to detect it. That's the issues. Okay. So concentration varies. For you better you go for the country specification for any specific sample. This technique can do anything. Okay. Okay. So this is a general. See, and the thing is, these courses we generally cover it like 2 weeks, 3 weeks, or a 1 month course it is. And you are having like a 1 day, so we are skipping many of the things and we are going forward. I'm sorry for it. And generally we have deleted most of the slides also. Yeah.
What are the limitations of this equipment for testing of manganese? There's a limitation of this equipment for testing of manganese?
See, most of the time, yes, there are detection capability for every equipment.
Yes. What are the limitations for this one for the ranges?
Manganese you can cover with AAS also, ICP also, MS also. If you have a 1 ppm level, then AAS can do it. Very accurate data. If it's a varying between less than 1 ppm, then we generally go for ICP OAS.
On the absorbance value, and that's how you get this straight line here. Now, when you aspirate your unknown sample, you'll get an absorbance value, and that is the extrapolated to concentration. So that's how you basically determine the concentration of your unknown. And it's important that you dilute your sample, that whatever metal you're looking at will basically fall within the linear range of the instrument. And each element that can be analyzed with AS have its own linear range, because at some point you start to get this plateau. And this is basically the non-linear range, meaning that the Beer-Lambert's law is no longer being applied. And that is the relationship, there's a direct relationship between adsorbance and concentration. So you have to calibrate within the linear range. And then when he speaks about detection capability, is the ability to detect here. Right? Each element within the periodic table, it's just you switch out the automation. So how there's a flame, you take out the flame and you install the graphite furnace.
Calcium, magnesium, and iron oxides, and some others like silica, like this. And each of them, they are on percentage scale. So
There are 2 ways again you can prepare. Most of the people or equipment, they generally operate equipment in an
Radiation interference. Then you have the spectral interference, like background interferences. So it's how you check and how you fix.
We use generally the spectral interference. There's a wavelength interference matrix, and second interference comes from environmental also. There's a lot of analytical procedure you need. So comes triple quadruple also comes. Okay, it depends upon your requirement. We are going for the multiple in a GC also, GCMS also, single quadruple, triple quadruple it comes, because that's why reduction limit, PPT level possible, simultaneous analysis, and the mix and inject sample directly. Wet dashing method, UOP 399, you read these methods are available. A different kind of method for every samples.
So I have a question. So like how you have a standard method here, and the method is said specifically to use an inductively coupled plasma instrument, but I don't have that, and I have an AS. It could meet the detection limit as well. But do I need to go through that validation process, or can I just make a technical justification?
See, most of this method will tell you how to prepare a sample. Most of the time. The method will tell you sample preparations. But only difference in that, in ICP OES, they won't say wavelength they will give, but in AES, they will some.
We expect we measure the energy emitted by the electron.
We want to check.
So with this single crystallographic, let this.
Then follow the method, check this. But you need to check every time these are things like accuracy, precision, reflection capability, sensitivity, linearity, working range, and robustness. If you go to ICP, it's a double. Again, it's a double in case of MS. Okay. This is a single element analysis. You need to one by one you need to do it. Here, multi-analysis, multiple analysis at a time, and this also multi-element. Where cheaper, simple, everybody can handle. Expensive, and some technical skills are required to handle this. And it's more expensive, and we should have more knowledge to handle the equipment. So these are about elemental analysis technique. So if you have any question,